In this video, we're going to start section P-4, factoring polynomials. Factoring a polynomial means breaking it down into its components. The easiest place to start is by factoring out a single term. It's just the reverse of the distributive property. If we had A times the quantity B plus C, and we used our distributive property, we would have AB plus AC. Now we're just reversing that. We're looking for common terms that exist in each, and then we factor those terms out. Now we're taking these A's and bringing them outside the parentheses, and we're left with inside the B plus C. Oop, and I guess that's what we just did here. We're just doing the reverse of that distributive property. So example 1, always read the directions. They're going to give you an idea how to attack the problem. And here it just says removing common factors. Nothing about factoring yet, just remove a common factor. Let's see here, I look in part A, and I see 6x to the third and a minus 4x. First, I look at numbers. Is there a common factor to 6 and 4? What are 6 and 4 both divisible by? Well, we can pull out a 2. And then the first term has an x to the third, the second term has an x to the first, so there's at least an x in each of them, so we can pull an x to the first out. Now let's figure out what's left inside. Since this is the reverse of the distributive property, you can almost think about this as we got to do a division here. We had a 6 and we divided out, or we pulled out a 2. What is 6 divided by 2? 3. We had an x to the third and we pulled out x to the first. What does that leave us inside? X squared. Subtract those exponents. 3 minus 1 is 2. And then we have our minus sign. Our coefficient here was a 4, but we factored out a 2. 4 divided by 2 is 2. And we had x to the first, we factored it out, so there's nothing left there. And these problems are really good because you can always double check your work and distribute and see if you get back to the original problem. 2 times 3 is 6, x times x squared is x to the third. And then we have our minus, 2x times 2 is 4x. So we can check our work and make sure we got it right. Let's see here in letter B. I'm just looking at coefficients first. I see a 4, a 12, and a 16. What can I divide into each of those? Well, we can pull a 4 out. And our leading term here is a negative. If we're going to factor anything further after this step, it'd be a good idea to pull that negative out with the 4. So I'm going to pull that out there. Let's see, we have an x squared, an x to the first, and this term does not have a variable x at all. So we can't pull an x out. We can't do that unless it's in every single term. So let's see what we're left with inside. We had a negative 4, and we factored that negative 4 out, so we're left with a plus 1 x squared. We had a positive 12 here. We factored out a negative 4. What is 12 divided by negative 4? Negative 3. And there's still an x attached to that. And we had a negative 16. What is negative 16 divided by negative 4? Positive 4. Again, you can double check by distributing. Negative 4 times this is our negative 4x squared. Negative times negative is positive. 4 times 3 is 12, and our x is there. And negative 4 times positive 4 is negative 16. So we factored out that negative 4. Our next question would be, can we factor this any farther? Well, what are the factors of 4? 1 and 4, or 2 and 2? Is there any combination of those that are going to add up to negative 3? And that's not going to factor any farther, so we're done there. The last one might be the hardest to see. We got this mess going on, and if you imagine a bigger set of brackets around there, and we have our plus sign in the middle. On the left we have one term, plus on the right of the plus sign another term. What is common to each of those terms? Well, we have this quantity in parentheses, x minus 2 here, x minus 2 here. So that's a term that can be factored out, even though it is a quantity. So I'm going to pull that outside these brackets, and I'm going to have x minus 2. Now I'm going to replace those brackets with just another set of parentheses. When we factored that quantity that I underlined and read out, what did it leave inside the brackets? What remains? Well, here we had a 2x and then a plus 3. 2x plus 3. And there's our factors. You've seen these before, most of them in Algebra 1, the remainder maybe in Algebra 2. Factoring special polynomials. Some polynomials have special forms that arise from the special product forms on page 30 in the book. You should also learn to recognize these forms so you can factor them more easy. So we have a difference of squares. Difference means subtract, and we all know what a square is. So here we have u squared minus v squared. It's always got to be a minus in there. Our first term squared minus our second term squared. And when we factor that, it turns into u plus v times u minus v. We have 1 plus and 1 minus. Remember, if we FOIL that out, the middle terms cancel. If we have a perfect squared trinomial, our first term is a perfect square, our last term is a perfect square, and the middle term is 2 times the first term times the second term. Well, that's going to turn into a perfect u plus v quantity squared. And the same thing for a minus in there. If we have a minus, it's just going to be u minus v quantity squared. It's our first term squared, our second term squared. The middle term is 2 times the first term times the second term. Remember, when you're multiplying that 2uv, it's not u squared v squared. It is just the u or the v. And these last ones, the cubes, I don't know if you've seen these in Algebra 2 last year or the year before. But we have a first term to the third power plus a second term to the third power. Well, we can break these up into 2 terms. One is going to be a binomial. The other is going to be a trinomial. And we'll go over these formulas a little bit more when we get to the examples coming up in a slide or two here. So example 2, remove a common factor first. Look for numbers or variables that you can bring out. We got a 3 and a 12. What is divisible by 3 and 12? Or what divides into those evenly? Well, we can put a 3 in there. We got an x squared. There's no variable here, so we can't pull out any x's. 3 times what is equal to 3? Or 3 divided by 3 is 1. And then we have a minus. 3 times what is 12? Or 12 divided by 3 is 4. And we still have our x squared. Now think about these special cases we had here. Our first term in this binomial, that's a perfect square. Here we have 4, that's a perfect square. Square root of 4 is 2, and x squared is a perfect square. So the square root of 1 is 1, the square root of 4 is 2, and the square root of x squared is x. So this is 1 squared minus 2x quantity squared. So that's a difference of squares, a perfect square minus a perfect square. And we can break that up into a sum and a difference, 1 plus and 1 minus. And our 2 terms are going to be 1 minus 2x and 1 plus 2x. So there we go. We've factored this down completely. First thing we did was remove the common factor. Then when we saw that, that left us with a difference of squares. And that broke down into a sum and a difference. Example 3. It's a little harder to see, but this is a difference of squares. First we have our minus sign, difference. What is the square root of 16? That's 4. What is the square root of x to the 4th? Well, that's x squared. If we square this, we get 16x to the 4th. And what do we square to get 81? Well, that's 9. So there are, it's sort of like our u and our v from that formula sheet. This is a difference of squares. So it's going to break down into a sum and a difference. We're going to have a 4x squared plus 9 and a 4x squared minus 9. Now you think you might be done at this point. We've identified a difference of squares and we applied our little formula and we got this. Can we break it down any farther? Again, we have a difference of squares. Square root of 4 is 2, square root of x squared is x. So that is quantity 2x squared. And then 9 is 3 squared. So I'm just going to bring this first term down. This we can't factor any farther. It's not a difference of squares. This is a sum of squares. And we can't factor that any farther. But this second term is a difference of squares. And we can break it down again. A 2x plus 3 and a 2x minus 3. And now it's broken down as far as it can go. We had to apply that twice. All right, example 4. And they give us a clue in the instructions. Factor a perfect square trinomial. So in part A, we have x squared minus 10x plus 25. And if we go back to our little formula sheet here, perfect squared trinomial, it's something squared plus, and at the end we have another something squared, and in the middle is 2 times u times v, 2 times these terms, and that'll turn into a perfect, or a binomial that's squared. So let's see what we got here. Our first term is a 1. This term is a 25. So the square root of 1 is 1, the square root of 5 is 5, and the middle term is 2 times these multiplied together. 1 times 5 is 5, times 2 is the 10 that's in the middle. And we also note that this is a minus sign, so our answer is going to be a quantity squared, and it's going to be x minus 5. You know, and myself, I don't even have this completely, you know, I don't use that exactly as we're supposed to. I still look at it this way. What are the factors of 25? 1 times 25, 2, 3, 4 don't work, 5 times 5 works. And then after that they would repeat. So let's see here. We have the factors of 25. What two of those add up to negative 10? Well, if we make this a negative 5 and this a negative 5, they're going to add up to negative 10. And if we multiply negative 5 by itself, we get our 25. So we would have our two factors as x minus 5 and x minus 5. Or you could write it as x minus 5 squared. Let's see here, this next one, letter B. Our first term, we see that it is a perfect square, 16x squared. The square root of 16 is 4. The square root of x squared is x. So that's our first term. Our last term is also a perfect square. That would be 3 squared. And our middle term, is it 2 times these multiplied together? Well, 4x times 3 is 12x. 12x times 2 is 24x. So our middle term does check out. So we're going to have some quantity squared, and that quantity is 4x and 3. And what sign goes in the middle? Well, our original problem had a plus and a plus, so this also has to be a plus sign. All right. That's the end, just about the end for this video. Here are some practice problems to try on your own. Pause the video, try these problems. Again, read the directions. They give you a clue as to what they're looking or asking you to do. Just factor out a common factor. Completely factor the difference of squares. They tell you difference of squares. Here is a perfect square trinomial, and the last one is just factor the trinomial. It doesn't follow any of the special patterns, though. So pause the video and give those a try. All right. So the first one, factor out the common factor. I see a 3, a 6, and a 9. What can I factor out of each of those? Well, I can pull out a 3. I got a z to the third, z squared, and just one z, a z to the first, so I can pull a z out. And let's figure out what's left inside. 3 divided by 3 is 1, so there would be a 1 there. We don't have to put it in. Z to the third divided by z is z squared. And then we have a minus sign. 6 divided by 3, there's a 2 left in here. We had a z squared, but we pulled one of them out, so there's one z left. We have a plus sign next, and then we had a 9. 9 divided by 3 is 3. We factored out a z, and that z would have been factored out in its entirety. And let's see, can we factor that any farther? Can we get this to factor into two factors? What is z squared? That's z times z. The factors of 3 that would add up to negative 2. You'd want to think it's a 3 and a 1, but there's no way to get the signs to work to get this to be a plus 3 and this to be a minus 2. You could get one or the other, but not the same at both, or at the same, not both of them at the same time. So this is as far as we can go, and they did give us a clue of that in the directions. It just says factor out the common factor. The only common factor was 3z. So let's see here, numbers 24 and 27. Completely factor the difference of two squares. Oops, let me just throw this in the garbage. So completely factor, and they do tell us difference of two squares. what squared is x squared? Well, that's our x. Minus what squared is 64? Well, that's got to be an 8. So those are our two things. That's sort of our u and our v from the formula box. So we're going to have a sum and a difference. An x plus 8 and an x minus 8. Are either of these a difference of squares? No, 8's not a perfect square. So for this problem, we can stop right there. Let's see, 27. 16 square rooted is 4. X squared square rooted is x. So that's our 4x quantity squared minus. Now let's think about this one. What do we square to get 1/9? Or I look at it, think about it, what's the square root of the numerator? 1. What's the square root of the denominator? 3. What's 1/3 times 1/3? 1/9. So there's our two factors, or our two terms. We're going to have our first term plus our second term, and then our first term minus our second term. If we FOILed it out, the middle terms would cancel. That's why there's no middle x term here. It's a perfect difference of squares. This is the perfect square trinomial. It's a lot like one we did in the examples. What is the square root of x squared? X. What's the square root of 25? 5. Is the middle term 2 times these multiplied together? 5 times x is 5x, times 2 is 10x. So our answer is going to be this binomial, the x and the 5 and that quantity squared, and because this middle is a plus, our binomial also has a plus in there. X plus 5 quantity squared. The last one, they just tell us to factor. You've been doing this since Algebra 1. It's not any of our special cases. So we just got to ask ourselves, what are the factors of 6? Well, 1 times 6 is 6. 2 times 3 is 6. And then 3 times 2 is 6. So we'd have the same term but reversed. We have a plus and a minus are our signs. So the signs are going to be the same. Which of these add up to -5? Well, if we make this a -2 and this a -3, those add up to -5. So x minus 2, x minus 3. And there's our two factors. Thank you.